So this is problem 3, intro to kinetics, and I already solved the first 2 problems, and now I just want to go ahead to explain how to solve this problem with the solution already posted on Canvas. So by now we expect you to know how to set up the table to find out the center of mass, set up the table to find out the mass moment of inertia. If you are not sure, go to the first 2 problems. Now just go ahead to explain this. We have 3 standard shape. The first one is the discs. And then we have a horizontal thin rod AB and the vertical thin rod CD. And in this case, they give us the centroid of this composite body at O, and go ahead to find out what is the length of DC so that the center of mass of this whole composite body will be located at O. So that is the first question. Want to find out what is L. And then the second is what is the moment of inertia of the assembly perpendicular to the page, and go through O. So basically IO. So as you can see, first we need to find out the location of center of mass. They give us O, but we need to find out L. So it's a little bit opposite to the first 2 problems. First 2 problems give you all the geometries, including the length of the vertical rod, everything. And then set up at the end, you find out Y bar. Now they give us Y bar. Go ahead to find out where is the, or X bar in this case, and go ahead to find out what is L. So right side, so we, in this case, a little bit strange. We make axis X, go to the left, and the point is from the right side, this point. So let me call that point is, let's see, A, B, C, D. So that point B, okay, from point B. We already have that. So with that, we have 3 shapes. The thin disc, horizontal, thin rod, 1.8 plus 1.5. So that one, it will be 1.3 meter. The vertical L, so let's put that L out. So for the second column, the mass, the thin discs, they give us 6 kilograms, so put 6. For the rod, either AB or DC, the mass is 2 kilograms per meter. So as you can see, this is 2 kilograms per meter times the length, 1.3, so you will have 2.6 kilograms. Similarly, you have L for the vertical rod and 2 kilograms per meter, so the mass of the vertical rod, it will be 2L. X bar, it will be defined from the center of mass of the standard shape. So let's call that E, G1, G2, and this is G3. Actually, G3 in this case, as you can see, same at point B. Right? So G1, where? This is G1. G2, thin rod, homogeneous. So it will be located somewhere there in the middle of the rod, G2. And B, actually that is also G3. So the X bar is from point B to G1. B to G1. So actually that is B, G1. From the origin to the mass center of the standard shape G1. So as you can see that it will be equal to 0.5, which is BO, 0.8, which is OA, and then plus the radius 0.2, you get 1.5 meter. Similarly, we have this one, it will be B, G2, and as you can see, G2, it will be the whole thing, these two, add together, the length is 1.3 meter. So G2 in the middle, it will be 1.3 divided by 2. Basically, that is 1.3 divided by 2. You have 0.65 meter BG2. And the last one, vertical, it will be G3 to B. So it's exactly the same. The center of mass of the vertical rod, same at the origin, that where we define from the right side, as you can see there, from the right side. So that is equal to 0. So go ahead to time the second column. with the third column. So you have 6 times 1.5, we have 9, 2.6 times 1.65, 1.69. Everything else times 0, it will be 0. Add them up, you have that. So from that, you will have x bar. Why not y bar? Because as you can see, this body symmetrical about x-axis, so y bar have to be 0. Only need to find out x bar. That unlike the problem 1. It's symmetrical about y-axis, so you only have to find out y bar. Okay? So from that, you can have x bar. X bar is defined from the center of mass. So basically, the center of mass of this whole composite shape is G, is actually the O. So it will be OB, 0.5. 0.5. So that you have 0.5 equal to this equation, sum of all the xm divided by sum of all the mass. So from that one equation, one and all, you will find out L equal to 6.3 meter, and that will be your answer for the first. Determine the L so that the center of mass of this shape located at O. So the first question. The second is, what is the moment of inertia of the assembly about an axis perpendicular to the page and passing through point O. So we make a table again to find out the mass center, the moment, moment of inertia about the axis perpendicular to the page and go through point O, which is the center of mass of the composite shape, including 3 standard shape that we talked in earlier. So 3 standard shape, again, we have it in there. G1, G2, and G3, and in this case G3 actually B, as you see. And for the thin disk, we already see that it perpendicular to the page. So basically, if you go to the reference that we talked earlier, go back to problem 2, that basically this one is, I just emphasize IZZ. Go through the axis perpendicular to the disk, IZZ, in reference. So you have 1/2 mr square, 1/2 the mass is 6, the radius of the thin disk is 0.2 square, so you have that 0.12. And then md square, it will be from the center of mass to O, right? O where you find out. So you have point A plus 0.2, it will be equal to 1. So let me write down here so that you have, so basically that one equal to OG1 equal to 1 meter. 1 meter. And then the thin rod, for the center of mass perpendicular to the rod, go to the center of mass of that thin rod, it will be 112 ml square. So it's 112 m equal to 1.3 times 2 kilogram per meter. So that is the mass. And then the L, the length of the rod, is 1.3. We have that 0.366. And then for the md square, it will be also mass time from the center of mass of the G2 of the AB to O. So that is, as you can see, that one where we want to find out, and it actually it equal to 0.65 minus 0.5, because that one, keep in mind, it will be 0.65 meter. So with that, we have here 1.5. So that one, as you can see, actually OG2. And with that, times that 2, we can get the third column. Similarly, ml square, now we already find out the L. For this one is 6.3 meter. Apply very similar 112 ml square. So you have that 6.3 times 2 kilogram per meter. And then times the L, 6.3. So you have 43.49 kilogram meter square. And then this is the mass again, 0.5, which is from T3, which is B to O, right? So you have that one. That one is go to O, T3, also OB. So F equal to 3.195. And then at the second and the third column, you get 3 number. And then you add them together, it will be equal to 53.2 kilogram meter square. And that is the answer, the mass moment of inertia about the axis perpendicular to the page and go through O, which is the center of mass of the composite body, including two thin rod, one horizontal AB, one vertical CD, and then the thinness 0.2 meter in radius. With that, I explained the problem 3 of the intro to kinetics.